guys, we're back with the most awaited video, the solution paper for October 2024, Pure Mathematics Paper 3. Let's get started. Here we have it, number one, solve for 0 to 360, the equation this, 3 tan square theta plus 7 sec theta minus 3 equals 0, giving your answer to 1 decimal places. Now, what you need to do, we need to have, in order to form a quadratic equation, we need to have the same terms here and here, right? So we can convert the tan square theta using this identity that we learned, that 1 plus tan square theta equals sec square theta. This gives us tan square theta equals sec square theta minus 1. We put this instead in place of the tan square theta, and after some simplifications, we get to this equation, which is a simple quadratic equation. Solving this using your calculator will give us two values. Sec theta will be equal to 2 over 3 and negative 3. Now we all know that sec theta is 1 over cos theta. Therefore, 2 over 3 becomes 3 over 2 in case of cos theta. Now 3 over 2, if you convert it into decimal, it will give you the value of 1.5. Now, if you remember that the range of cos theta is from negative 1 to positive 1. So this value actually exceeds the range, therefore this value is not applicable and we will not use this value. The other value that we found is negative 3. So 1 over cos theta, which is sec theta, is negative 3. Therefore, the cos theta will be equal to negative 1 by 3 actually. But we don't need to, in order to simplify or like for better calculation, we ignore the negative sign for the moment and we calculate the first quadrant value or the first quadrant theta value for cos inverse 1 over 3. Then we can minus this value, or we can, so cos is negative in second quadrant and the third quadrant, and it's positive in the first and fourth quadrant. So since it's negative, we need to find the value of we need to find the second and third quadrant values. So, and for that, we can just do 180 minus the first quadrant value, and we get this. For the third quadrant value, we can just do 180 plus the first quadrant value that we get. So this is our first quadrant value, this is theta, and therefore the actual theta that you need will be 180 minus this, and then another one is 180 plus this, and then we get 109.5 and 250.5 degrees. Moving on to the next question, we're shown this figure, and then it says that the equation of the curve is x equals 2y squared plus 5y minus 6. Then A, find dy by dx in terms of y. dy by dx in terms of y. So here we can see that our x is our subject, while the equation has been placed in terms of y. Therefore, we can easily find out that dx by dy, which we did here. Since x is this, dx by dy is 4y plus 5, and therefore if we just reciprocate it, then we get dy by dx is equal to 1 over 4y plus 5. This is our answer. Then the point P lies on the curve and is shown in figure here. This is point P, and we can see that this point, the tangent to this point is a straight line, which is parallel to the y-axis, which means that the gradient of this line is actually undefined. Why? Because it has since what do we know? M, or the gradient, is the difference del y by del x. Here del x is 0. There is no change in the value of x. X is constant. Like here, if we say that x is negative 5 here, so it remains the same. There is no change for this line. Therefore, del x is 0. And therefore, if any value divided by 0 is undefined. So we already know that for the gradient, the denominator of the del x of the gradient will be 0. Now, what we asked, they had given that the tangent to the curve P is parallel to the y-axis. We have seen that. And then we're asked to find the coordinates of P. Now, As I've told you, mentioned before, that the gradient, the denominator of the gradient for such a line will be equal to 0. It has to be. Therefore, we can just do, since we know the gradient, which is dy by dx, is equal to 1 over 4y plus 5, this is our denominator. This denominator will be equal to 0 for the line. Therefore, 4y, and therefore we can find the value of y, which is negative 5 over 4. And so from the equation, from the main equation of x equal to 2y squared plus 5y minus 6, if we input the value of y that we found here, we can find the x coordinate, and therefore the coordinate of p will be minus 73 by 8 and minus 5 over 4. Moving on to the next question, we have number 3. This is a really tricky question actually, because you will be required to draw the graphs. Okay, so let's see. Figure 2, this figure 2, this figure, the initial figure, shows a sketch of the curve with equation y equal to f of x, where f of x is 2x squared minus 10x. Okay, so this curve, the equation for this is y equal to 2x squared minus 10x. All right, then A, solve the equation for f modulus of x is equal to 48. Okay, so for modulus of x, we already know that means that the values, the negative values of x, say the negative 1 value or negative 2. So every single negative value of x will give an output that is equivalent to the positive value of x. That means the value, that means f of x for x equal to 1 will be equal to the f of x for x equal to negative 1. Since it's negative 1, since it's modulus, this negative 1 becomes 1, and the same value is repeated. Therefore, if we actually draw the graph, it will be like this. For since this from this 0 point or from the origin, the graph just repeats itself. The graph just mirrors itself along the y-axis as the line of symmetry. Okay, so every single value for the negative values, the same values, the y values are equal for the positive values. You see, they are the same. So it repeats itself. So if we can just find the value for the positive axis, like the point where this curve cuts 48 along the positive x-axis, we know that along this negative x-axis, it will be the same value at where this curve will cut the 48 mark, the y equal to 48 line. So if we just calculate it, if we just put it without the modulus sign, like 2x squared minus 10x equals 48, we find that x is equal to 8 and negative 3. So since we have modulus, we are going to ignore this negative 3 mark, because this negative 3, where is it? Here, this value, this negative 3 for this modulus sign will never be there. It vanishes. We don't consider this entire part of the curve. This curve mirrors itself from the origin, just like this, like the positive x-axis. Therefore, since we know that at the 8th mark or the 8th unit, this curve cuts the line 40y equal to 48. Therefore, along this side too, like the negative x-axis, it will be the negative 8 mark that will cut the y equal to 48 line. Therefore, we can say that our x value will be equal to plus minus 8, right? It is easier to solve the question if we just draw the graph and intuitively figure out that these 2 points will cut, the curve will cut y equal to 48 at these 2 points. Okay, then we move on to number B, which says find the set of values of x for which modulus f of x is greater than or equal to 5 by 2x. Okay, for this, so since it's modulus of x, the f of x can be either this value or the negative value, which means like it can be minus 2x squared minus 10x, and it doesn't make a difference since it's covered by the modulus sign. It doesn't make a difference. That means we can take two values, we'll get two values, one for this and one for minus 2x squared plus 10x. And we do exactly that. Once we take minus 2x squared plus 10x equal to 5 by 2x, and one other time we take the positive normal equation, and then we can find the two values for x, which is we have found that x equals 15 over 4 and x equals 15 over 25 over 4. Now we need to find out that which value, like what are the ranges. So here in the question, it says that it will be greater than this line, 5 by 2x. Now this is a straight line, right? Because a straight line has equations y equal to mx plus c. Now this is mx, this is m, and this is x. Therefore, the line should look like this, going through the origin, this green line, where this is y equal to 5 over 2x. Now this line, and this is our curve, like the modulus of f of x. Since it's the modulus of f of x, y cannot be negative. Therefore, the negative values of y will mirror itself along the x-axis, and therefore we obtain this curve. And we can see that the part of the curve that is above this green line is this part, right? Is this part, and this part is below this 15 over 4 mark, which means that x must be less than or equal to 15 over 4. And in this case, in this part, like 25 over 4, you can see that along this part, the curve is below the line, and the curve becomes greater than the line again after this 25 by 4 mark. See, from this point on, the curve has greater value than this line. Okay, therefore x will be greater than equal 25 over 4. And this is exactly what we have written, that x will be greater than equal to of 25 over 4 and less than equal to 15 over 4. Now moving on to the next question, we have number 4. The number of bacteria on a surface is being monitored. The number of bacteria n on the surface t hours after monitoring began is modeled by the equation this. Okay, find the initial number of bacteria to the surface. So if we're asked to find the initial number, that means initial means when time is 0. Therefore, we just put t equal to 0, and then we have log to the base of 10 and equals to, and therefore n equals 100. This is our answer to A or B. Show that the equation of the model can be written in the form n equals AB to the power t. So we have to write this equation in the form of this, or to solve this equation, we can just reverse engineer it. We can start from this equation, which it's just more easier to convert this equation to this logarithm form rather than converting this into this. Okay, so n equals ab to the power t. Therefore, if we take log on both sides, right? If we can take log on both the sides of the equal. Therefore, log 10n equal to log 10 base ab to the power t. And since it's a times b, we can write them separately as log 10a plus log 10b into t, since this is the power. So the power goes in front. Therefore, this t can be also written here. So t, and then log 10n is equal to log 10bt plus log 10a. Now this looks like a straight line, right? This is exactly a straight line. So log 10a is the c value, where this equation here, c is 2, and this is m. So m equals 0.35. We can write this like this. This is m, this is c, and from here we can find that a equals 100 and b equals 10 to the power of 0.35, which is equal to 2.24. And so, since we have found the value of a and b, we can write that n equals 100 times 2.24 to the power of t. Okay, before we go moving on to the next question, give me a sec. And we're back. Okay, moving on to number C. Hence, find the rate of growth of bacteria on the surface exactly 5 hours after monitoring begins. So here we have T equals 5 for this equation, for this question. And if we just put the value of T of 5 into this equation that we have found in B, we can, okay, so we're told to find the rate of growth. So rate of growth will be dn by dt, right? The differentiation of n in terms of t. So dn by dt is 100 remains, and e to the like a to the power x. This is the formula for the d by dt, d by dx of a to the power x, which gives us 2.24 to the power t times ln 2.24. Okay, if you're confused about how this came, this is the formula, like d by dx of a to the power x will equal a to the power x ln a, right? We know this formula. Okay, so putting the value of t equals 5 into this, we find that there will be the growth rate is 4,550 bacteria per hour. Okay, number 5, trigonometry. A says that show that sine 3x can be written in the form p sine x plus q sine cube x. Okay, sure. So we have sine 3x. We can write this sine 3x as sine 2x plus x. And if we use the formula for sine a plus b, we can get this. So sine a plus b is equal to sine a cos b plus cos A sine B. We all know this. So sine 2x cos x plus cos 2x sine x equals to 2 sine x. Um, okay, yeah, so 2 sine x cos x plus sine x 1 minus 2 sine square x. This just we have found this just simplifying and simplifying. Um, Okay, so yeah, so here we have converted the sine 2x to 2 sine x cos x, and cos 2x we converted to 1 minus 2 sine square x, and then we simplify it further, and this cos square x becomes 1 minus sine square x, and all this simplification gives us this value of 3 sine x minus 4 sine cube x. So therefore, you know that p is equal to 3 and q is negative 4. Now B, hence or otherwise solve this equation 2 sine 3 theta equals to 5 sine 2 theta. Okay, so we have already found that sine 3 theta or sine 3x can be written in this form. If we can use this form to solve the next question, so 2 sine 3 theta can be written as 2 times 3 sine theta minus 4 sine cube theta, and this equals 5 times 2 sine theta cos theta, just breaking down sine 2 theta here. Next, if we just simple simplification, simplification gives us this equation, and therefore we can write that sine theta can be 0, or this figure 8 cos square theta minus 10 cos theta minus 1 is equal to 0, and solving all of them. So this value gives theta equals to 0. So this is like theta equals to 0. That means this line, this x-axis, therefore, sine is actually positive in this quadrant and this quadrant. So I can write 180 minus 0 equals 180 degree. Also, 360 plus this should equal is also like sine is positive here. That means 1 revolution, and I can also like add the angle found, which is 0. Therefore, 360 plus 0 will be 60, and this is actually in our range. We were told to find theta is less than or equal to 360. Therefore, since this is in our range, we also have to put in this value. So here we have 3 values, and from this part of the equation, we get 2 values. We get 2 values, but one of them is greater than 1, so this is not applicable. We only use one value, and from this value is negative. That means we have to find the angles in the second and third quadrant. And finding this, you can do this easily. We have this two values. Therefore, in total, we have four values. We can ignore the 0 degree. This doesn't give any real value actually. Okay, next question is about functions. Okay, the functions f and g are defined by f of x equals this and g of x is this. Find g of f of 2. So since it's g of f of 2, we have to input at first, we have to put this entire value of f of x inside this x of g of x. So that would actually give us so there are two ways to do this. One thing is just we can first we can find the g of f of x, and then just put the value of x of 2. And the other way is at first find f of 2, which we have found here, like 6 minus 21 by 2 times 2 plus 3. We found 3, and therefore this value of 3 is going to be inside of g of x. So g of x will be g of 3. Therefore, yeah, look at this g of 3, and so this is much more easier. But also you can also do the at first find this function of g of x, and then inside that function that you have found, you can input the value of x equal to 2. Okay, B, find f inverse. Okay, so for inverse, we take this as y, right? We take this as y, and then what do we do? We take this as y, and then we try to make x the subject. So we made x the subject. You see, so here they have done it a different way. Here, what they've done is just there are two ways. One is that you find this y equals this, and then you make x the subject, or you just shift the x and y. So in place of y, you write x, and in place of x, you write y, and then you try to make y the subject. It's the same thing. It's either this, or you can also write as x equals 3y plus 3 divided by 12 minus 2y. In this case, you just write f inverse x is equal to, and just convert all this y into x. So 3x plus 3 divided by 12 minus 2x. All right, okay, so this is our f inverse x. And for the domain of this function, this domain will actually be the range of this f of x. As we know that the domain of f of x is the range of f inverse x, while the range of f of x is the domain of f inverse x. So we need to find the range of f of x of this function here. Here we have like the domain was x greater than equals 0. Now, if we put the value of x equals 0 in this function f of x, we get y equal to -1, and where y is 0, we have x equals 1 by 4. Now, if we just draw the graph, we find that here these are the 2 points that we got, one for x equals 0 and one for y equals 0. Now, if we take the limit of this function, we actually see that there is an asymptote, that this value, when x approaches infinity, the value of f of x approaches 6, but never touches 6. So the y equal to 6 line is an asymptote to this function. Therefore, we know that the value of uh, the value of x for the function of f inverse x, the inverse function, will vary from -1 here, since x is greater than 0. Therefore, this is the lowest it can go. So from -1 to the highest, which is 6, right? Therefore, our domain for the inverse function is -1 to 6. C says that solve the equation g of x equal to 126. G of x means we have to put the value, this entire value of g of x into this x. So that is what we do. We put this entire value, x squared plus 5, into this x. And we'll say x squared plus 5, then whole square of that plus 5 is 126. Simplifying gives us that x is plus minus root over 6. Okay, next, moving on. Question number 7. The curve C, this C, has the equation y equals f of x, where f of x equals x cubed root over 4x plus 7. Show that the differentiation of this function is this. This is easy. We just do the differentiation. The f of x is this, and so f inverse, the first derivative would be we keep this x cubed, and then we differentiate this part. And for next plus, we keep this part and we differentiate x cubed, right? So doing this formula, we get to this point where we can clearly see that k is equal to 7. Now B, find the coordinates of P. The point P shown in figure 3, this is the point P. This point P is the minimum turning point on C, okay? So we have to find the coordinates of P. So since this is the minimum point, this means dy here, dy by dx is equal to 0. That means that our f, the first derivative of x, is equal to 0. So if we just put 0, we can easily get the x coordinate, which is -3 by 2. And from the function, we get y2. So this is our coordinate of P. Next, C says, hence find the range of the function g defined by g of x equal to -4 f of x. So see, g of x is actually a stretch, and it's a vertical stretch, right? It is a vertical stretch. See here, g of x is a function when f of x is reflected in the x-axis. It's reflected because it's negative, right? There is a negative sign. That means it will be reflected. The negative values will become positive values, and the positive values will become negative values. So g of x is a function is which when f of x is reflected in the x-axis and stretched 4 units vertically. Okay, the function g of x is sketched in the above figure. Okay, so this is the function of g of x that we can write. It's a stretched version of this, right? This is like a stretched version, and so what did they ask? We have to find the range of the function. Therefore, the maximum coordinate of g of x will be so the x value remains the same. X doesn't change. X is -3 by 2, but the point P, since it stretches vertically by 4 units, that means this value stretches by 4 units. That means -27 by 8 times 4 becomes -27 divided by 2. But also since it's been reflected, there is a negative sign, so this minus becomes positive. So our y value becomes positive 27 by 2. And we were asked to find the range of g of x. So we already we here we see that the domain is x is greater than or equal to negative 7 by 4. If we just put this value into the function of g of x, we get that since it has a maximum point, you see, this was the minimum point, which was okay. So yeah, so this will be the maximum point, right? This will be the maximum point, and therefore we can write that the function of g of x less than that value is less than this value of 27 by 2. Here we go. This is our range. Now, D, in D, number D, they ask for that find the coordinates of the point to which Q is mapped when C is transformed to the curve with equation. This, okay, so here we have multiple transformations. One is we have a translation here, minus 3 by 2. So we have a translation where the x, where the graph is moved towards the right by 3 by 2 units, right? So it moves to the right by 3 by 2 units. It's a translation. And then the y values, right? The y values. Oh, before that, there's a stretch, right? There's a vertical stretch. So it's the the graph is stretched vertically by a factor of 40. And then the resulting graph is moved downwards by 8 units. Okay. So there are two translations here, two translations, and one stretch, right? Straight TCH and stretch, the factor is 40 vertically. And well, the two translations are one is vector 3 over 2, 0, and the other is 0, negative 8, right? Okay, so if we have, so they ask that what will be the coordinates of Q in this transformed graph. So we see that Q, where is Q? Okay, the Q had coordinates of 1 over 2. Therefore, we see that the translation for the x-axis is like negative. It moved to the right by 3 by 2 units. So we're gonna add. So we add 3 by 2 with 1 over 2, which gives us the x coordinate of 2. And then y is stretched vertically. That means 40 times 3 by 8, and then the resulting graph is moved downwards by 8 units, therefore minus 8, which gives us 7. Therefore the q, the new coordinate of q, will be 2 and 7. Now we have number 8. Okay, we have a graph is given, and then the heart rate of a horse is being monitored. The heart rate h measured in beats per minute is modeled by the equation this, where t minutes is the time after monitoring began. Okay, figure 4 shows the sketch of h against t. State the initial heart rate of the horse. Okay, so initial heart rate means t equals 0. So we just put t equals 0 here, and we clearly see that the initial heart rate will be 32. You see, if t is equal to 0, all these values become 1. Therefore, 32 plus 40 minus 20 is 52. Then B says, okay, in the long term, the heart rate of the horse approaches L. Okay, this value would be like L, like, right? This value would be L. This value is L. So okay, so state the value of L. Okay, state the value of L. That means this is so the value reaches at a constant rate. So if we put that t is 3 approaches infinity, so L the value uh, of the equation, the value of h approaches L when t approaches infinity. Therefore, if we just put infinity in this values, so negative infinity e to the power negative some infinity is like is 0, right? So these two forms become 0, and then so we're just left with 32. That means L is the least value, which is 32. So C, the heart rate of the horse reaches its maximum value after t minutes. Okay, so it reaches its maximum value here, this maximum value after t minutes. So this value, so we have to find the value. To find this, we just find the rate dh by dt, and then this dh by dt will be equal to 0, and solving this equation gives us that t will be equal to 1.158, right? Yeah, these are simple simplifications. Next, see D, it says that the heart rate of the horse is 37 beats per minute after m minutes. Show that m is a solution of the equation. Okay, so we are given that age is actually 37. Therefore, the equation becomes 37 equals this value, this whole equation. And if we solve this, we get, if we just simplify further, we get to this point that t, if we are making the t the subject, since we have to show this, like making t the subject. Therefore, solution solving this gives us this equation. You can just look into further into this lines of equations, the simplifications. These are pretty easy to understand. Then E1, okay, so now we have iteration using the iteration formula. Find to 47 places the value of T2. Okay, so to find T2, we have to put the value of 10 into this equations, right? So for T1, T2 is 5 ln 8, right? So we put the value of 10 in place of T, uh, and we have this value. This will be our T2, and later we are asked to find the value of M. Okay, so for M, we have to find like at least like 5 iterations at least to find out that where it reaches a constant state. So if we keep doing this iteration, if we keep putting this value into here again, and then the result gets put into here again, if we keep doing this, we'll see that this the value of tn reaches at a constant rate, which will be this 10.3955. Next question, number 9. This here we have given a function of this. So this is our y equal to f of x, this curve. Then find the derivative of x. This is pretty easy. We can find the derivatives by the division rule, right? So this is squared and this stays. We differentiate the other value. We differentiate this value, the numerator, and then minus the numerator stays, and we differentiate the denominator. And further simplification brings us this value. Next, we have the line L is the normal to C at point P to 6. Okay, so that this line L is normal to P here at this point P, which has a coordinate of 2, 6, right? Okay, show that an equation for L is this. Okay, it's pretty easy. So we need to find the equation of a straight line. Right. So what is the equation for a straight line? Y minus y1 equal to m into x minus x1. So what do we need? We need the gradient. We already know the gradient of this curve, which is the differentiation, the first derivative. If we just put the value of 2 here, we get the gradient of the curve at P. Therefore, the gradient of the normal would be negative 1 by, so we know that m1 into m2 equal to minus 1. Therefore, m2 is minus 1 by m1. Therefore, we get this value, minus 5 over 6. So y minus y1 equal to m times x minus x1 gives us this equation. Next, we write f of x in the form ax plus b. Okay, so long division. We just divide this into, we just do long division, and we have a remainder of minus 5 over 2. So this gives us 3x plus half plus minus half over 2 divided by this divisor. and therefore A, B, and D values can be found. Now D, the region R, this region R, um, is bounded by C, this curve C, this L, and the x-axis. Of course, use algebraic integration to find the exact area of R, giving your answer in the form P plus. Okay, if the integration now. Okay, so for now we have to find the range. If we are to do integration, we need to find the range. So we can just divide this area into two parts. One, this we can divide this in from here, this P point. So if we draw a straight line, right, this gives us this extra rectangle, right? This extra triangle. I'm sorry, this is a triangle. So this has a height of 6 and a base of. So to find the base, right? This line L crosses the x-axis when y is 0. So we already know the equation of the line. If we put y is 0, we have that x is equal to 21.2. That means the base, right? The base of this triangle is 21.2 minus the value here. Now, how do we find the value here? We know p is 26. That means this is 21.2 minus 2, right? This is the value. This is the base, and 6 is the height of the triangle. So we already know this area. We already know this area of triangle. So now we just need to integrate from this part to 2 to find the area under this curve. Now, how do we get this value? We just put that here at this point, there is no y value, so y is 0. Therefore, in this equation of the curve, we put y is 0. Therefore, it becomes this value, like where um it didn't show this here, so okay, let me show you. What happens is if we put y equals 0, so 0 equals 6x squared plus 4x minus 2, and so simplifying this will give that x equals, in the positive direction, 1 over 3. This is where we'll find the x value. So the integration will be from a range of 1 over 3 to 2 here. Here we have from 1 over 3 to 2, 3x plus 1 by 2. This is the f of x in partial fraction dx, and integrating this will give us the value 20 by 3 plus 5 over 4 ln 1 by 3. Okay, right. Okay, this is our end value for the integration. Therefore, the entire area will be the addition of these two values, right? This area was half into base into height. Sorry, there is a mistake. This would be 21.2 minus 2, right? Yeah. So you get this value, and yeah, adding these two values will give us this, where our P and Q can be found. And this is the end of the paper. Wow, this was really fast. I hope you understood each question. And the PDF of this solve will be given in the description. Thank you. This is all for today.